newest method, but the sampling of sample over time and then test. So this one is not monitoring throughout, but we monitor it at regular time intervals. So what is a sampling method? Sampling method works like that. We will prepare known concentration of reactant. We will take note of the temperature, and we'll pour everything together and start our stopwatch to allow the reaction mixture to start reacting. And at our pre-decided time interval, we will draw out we draw our sample at a suitable time interval. Um, Now, as we use the pipette to draw out the sample, we must know that we are just transferring the reaction mixture to another container, which in this case is the pipette. The chemical reaction is essentially still ongoing inside the pipette. So in order for us to slow it down, we will need to do this thing called quenching. And to quench it, either we have chemical that is able to stop the reaction or slow down the reaction tremendously, or we use dilution or low temperature to slow down the rate. And after we are done and collect different samples at different time, then we will need to execute the titration to determine the concentration of reactant or product in the reaction mixture at time t. So then this experiment is actually pretty tedious, and we have hands-on experience with it. Now, ways to quench include, like what I mentioned, sudden cooling, ice bath, dilution by adding excess solvent, or if you combine the two, we can add ice water. Addition of excess quenching agent. Now, this quenching agent are actually reagent that will slow down, if not stop, the chemical reaction that is pertaining to the chemical reaction. Okay, so these are the quenching methods that we could have. One example that we have will be an alkaline hydrolysis of ester. Well, the solution of ester and alkaline of known concentration is mixed, and the time of mixing is noted at fixed time interval. We will draw out sample of the mixture, and then we will add a large excess of ice water. So it's ice, it is cooling it down, it's dilution. Both of them is doing the job of a quencher. Then we will take this sample to titrate with the alkaline, to titrate the remaining alkaline with a standard solution of acid to find out how much alkaline is left. This is quite demanding on students, really, because most of us are not so quick in the manipulation of pipette. So the drawing a sample at that time can be a challenge for many. Adding it to the quencher timely is also a challenge. And most importantly, you only have one sample at that particular time, which also means that you cannot repeat and you cannot fail, you cannot overshot that particular titration, because if you overshot, there's no way you can repeat it. So it can be quite stressful in the actual execution in that. So sampling method for the iodination of propanone, meaning in this case we have propanone, iodine, and acid being prepared, and at constant temperature we will add it to the reaction mixture, allow them to react by starting the timer. We draw the sample out at time interval. We'll quench it by using sodium carbonate to neutralize all the H+, removing the catalyst. Therefore, you will slow down the reaction tremendously. And then all the samples taken at different time, of course, we need to carefully label them. If I'm not able to do the titration within the time interval gap, then we will have to perform the titration very carefully to find out the concentration of I2 left in the reaction mixture at time t. So if you were to compare the monitoring physical property method versus the sampling method, the advantage of monitoring physical property will be the fact that it is really way easier to carry out, and it does not disturb the reaction mixture. What do I mean? Because when you do sampling method, your pipette need to go in and you need to draw and you need to adjust. So your reaction mixture is being disturbed. You actually need to ensure that you have sufficient reaction mixture to go through with all the sampling. So say for example, you plan to take 7 samples throughout, and each time you are taking 25 cm cube, you can do a multiplication. Your reaction mixture actually needs to be quite a large volume, which is why many a time this sampling method requires you to take a 10, if not a 15 cm cube sample instead of the regular 25. But of course, we have all kind of questions with different volume as well. Moving on, we'll be looking at the discontinuous method.